Thank you, and good morning. My name is Ian. I'm leading a team at Amazon Web Services focused on developer evangelism, developer relations, so helping software developers understand how they can use the cloud to build applications in a different way. And I have a sort of talk here which is in two halves. The first is to share a little bit with you about how we work and about how we think, about how we build products and about how we create services. So I have a little bit of a 10 or so slide presentation just to talk a little bit about some of the practices and approaches that we use at AWS and Amazon in building new products. And then as a case study in what kind of services that results in us creating, we're going to dive into some topics around machine learning and artificial intelligence in the cloud, and we'll talk about how by applying this kind of thinking we've built a new category of services for AI and ML developers. So that's going to be the second part of the talk. We've got plenty of time, and this is quite a small group, so I'm very open to interruption. If you've got anything that you want to ask or challenge as I talk, I'll bring the mic to you so that we can get that on the audio track for the recording, but I'm very open to any questions that you've got. If you want to interrupt me, disagree, agree, ask a question, please feel free to do so, okay? Before we get into that, let's just talk briefly about where AWS is today and where we came from. So AWS is a really successful and significant part of Amazon.com. So significant, in fact, that we are currently generating run rate of around $27 billion a year. And the business is growing at roughly 46% year on year. So this is the third quarter 2017 versus the third quarter 2018. So there's a lot of usage of this platform and a lot of growth in AWS, which is driven by nothing more than customers choosing to use the services that we provide. And that means that we have millions of active customers using this platform every single month. So it's a very broadly adopted set of services. But that usage really began with one particular type of customer. So if you go back to 2006, when we launched our first AWS services, we launched a couple of different services that year that are still around today. One called Amazon EC2, which is the Elastic Compute Cloud. This is a service for running virtual machine workloads on AWS operated infrastructure. And then the second is a service called Amazon S3, the Simple Storage Service. It's a service for storing and retrieving data at any scale in a way which is durable, and today benefits from a lot of additional features as well, but that was the initial vision that we had in mind for that service. Those two service offerings were unique in that they were utilitized, okay? So customers could use compute resources and pay for them by the hour. They could spin up machines using an API at day one, and they could return those machines back to a pool of capacity when they'd finish with them, and they would get a monthly bill for consumption. And with S3, you would pay for the amount of data that you had stored on the platform, multiplied by the number of hours that you had it stored for. Same kind of thing, utilitized data storage service. So what sort of characteristics did those services have at day one? Well, they were feature light. Okay, so we didn't have most of the features that you will probably know of in EC2 or S3 today, but they still had unique economic characteristics. They made a really good platform, created a really good platform for anybody that had variability in their application workloads or variability in their business, or maybe viability questions about their business. So we're going to create something here that requires infrastructure, but we don't want to purchase that infrastructure in case this business experiment doesn't work out too well. What kind of customers fit that profile? Well, the early answer to that was high growth tech startups that wanted to create brand new products without having to invest capital in infrastructure. This was exactly the first cohort of customers that chose to adopt AWS back in 2006. And today we're very lucky still to be the de facto choice for brand new tech companies. This is a really interesting question that I like to ask customers, particularly customers with companies on their name tags like Barclays, you know, well-capitalized financial services organizations. So just imagine for a second that you've all left those banks that you work for, okay, and you're going to start a brand new venture that relies on technology in order to operate, to communicate with customers, maybe host a website. Maybe it's actually a technology product, a software as a service, or some other kind of technology product. Who here would spend their own money or their investors' money on hardware? And who here would spend their investors' money on software products or software licenses that they actually owned? Okay, absolutely nobody. If you're sitting in the front, I'll just reassure you, okay? You're not the only people that didn't put your hand up. Nobody behind you put their hand up either, okay? And there's a reason for that. This is just the new way that we think about technology. If we're starting a venture, we don't buy technology. We use it and we pay for its consumption. And that actually fits into a few different models. Mostly it's about subscription-based software services. So we want a CRM, a messaging application. What do? We go out and find one which somebody else has built. We subscribe to it. We pay a few dollars a month for the privilege of using it, right? And where do you think those applications get built? They get built in the cloud. They get built on platforms just like AWS, okay? But if we are writing custom software or building custom products where there's more integration or real software development work to do, we're also going to be using tools to integrate, test, and manage the software build process. We're going to be deploying that software into the cloud, and we're going to be using all kinds of features that are native to cloud computing platforms to allow us to move more quickly and build less stuff, okay, and build more features, build less infrastructure components. And that's really the mindset that means that AWS is the preferred choice among startups of all sizes, from the brand new 2-person companies that I was meeting last week at Web Summit in Lisbon, Portugal, right the way through to companies like Slack or Twilio or Pinterest or Airbnb. They're all built on and running on AWS, whether it's 2 people in a bedroom or a garage, or 2,000 people in a very nice office in downtown San Francisco. They're still using the cloud as a primary platform. However, that is not the whole of the picture today. Today you've also got, many of you will come from organizations like this, you've also got really substantial usage of the cloud inside large enterprises. And here, usage broadly falls into 2 categories. So there's modernization of existing infrastructure. I don't want to run data centers anymore, or I don't want to run my own big data infrastructure, or I don't want to use my own computing resources for my HP simulation workloads or whatever it might be. Part of the regular capital planning cycle when it comes to replacement time or reinvestment time for technology, larger organizations are thinking about alternative sourcing models that, again, allow them to move the slider on how much I have to do to get a dollar's worth of business value out of that investment. So that's the first thing. And then the second thing is these companies are at risk and under threat from the kind of companies on the previous slide. So it's very easy today to build super compelling, really user-friendly, easy to access digital services, right? We can all do that using cloud platforms and software development tools that make it really easy. And that is really lighting a fire under more established brands that have a reliance on technology in order to serve their customers, but don't have the agility in order to respond in the way that startups can respond. So the solution to that in many big companies has been, we're going to inject some of this cloud into our development processes to help us build software more like a startup, to be faster, more agile, more responsive, lower cost, more experimental. And that's the second big use case that we see inside larger enterprises. So you could take someone like NL, for example. They're a pretty conservative company. They're the largest utility, former state-owned utility in Italy, one of the largest retail energy companies in the world. They have investments in many other countries around the world besides Italy. They're building their next generation power network management technology using AWS. So it's an Internet of Things application that allows them to instrument the power network, manage it more efficiently, and serve their customers at lower cost and in a more effective way. So they're injecting cloud-based technology into a pretty traditional enterprise in order to drive towards those kinds of outcomes. Okay, we could talk about many other customers here doing similar things. That's just one example. So lots and lots of usage in the enterprise. The other thing that's changed over that 12-year period is the breadth of services that are provided by the platform. We started with just 2, EC2 and S3 that I've already mentioned. Now we have over 125 different services, okay, covering all kinds of different usage requirements. Just within EC2, we have over 15 different types of compute platform. In fact, we have more than that now because just last week we added 2 more new ones. So we have over 17 different types of computing platform available to you just inside that one service. And we've opened up and developed whole categories of services for things like analytics and data management, or machine learning and AI, which we'll talk about later, or mobile application development, as well as investing a ton in information security and compliance features that enable customers to establish and maintain and have visibility over the right kind of controls for their data within this platform. So there's a huge amount of innovation, okay? And that doesn't show any signs of slowing down anytime soon. In fact, quite the opposite. Last year we shipped 1,430 new features. 2 weeks today, we'll be starting a small event in Las Vegas called AWS reInvent, which a few of you might have heard of. Last year we had over 43,000 attendees at this event. This is our global user education conference. And I am betting that we have a large number of service announcements that are going to come at that particular event. So we're going to at least keep up with this pace of innovation for 2018, if not exceed it substantially. So we're doing more and more stuff all the time to ensure that we're meeting the use case requirements that our customers have, and that we're closing feature gaps and making the service as complete a platform as it possibly can be for customers to use. That's how we think and how we work. But I really wanted to dig into that in a little bit more detail, spend a lot more time talking about precisely how this works in practice inside the organization. What are some of the processes? What is the mindset that we have when it comes to running a business like Amazon Web Services, and how do we think about things like innovation, structure, controls in order to enable us to move so quickly and to scale the rate at which we're doing things? Has anyone ever tried to consistently do twice as much stuff every year as they did the year before? Like twice as much in the gym, twice as much time with your family, twice as many hours in the office? How does that work out for you? It's basically impossible, right? There's a finite amount of time. So we have to be very circumspect in the way that we organize ourselves in order to enable us to achieve those outcomes, enable us to drive that hockey stick of innovation. That's what I want to spend a little bit of time talking about. There's some simple tricks and tips that we use to enable us to do that, because on paper it looks like magic. If you try to geometrically increase your output every year, you know, it causes issues more than it causes success for a lot of companies. So I want to just talk about that. Okay, so the first thing is this. You probably heard this from people at Amazon. If you've ever spoken to anybody from Amazon, they'll talk about a few things. First thing they'll probably talk about is leadership principles. Okay, these are the behaviors or values that we use to manage Amazon. They come from the senior executive team, basically from Jeff Bezos, Andy Jassy and Jeff Wilkes over on the consumer side of the business. Those are our two CEOs, obviously working directly for Jeff Bezos, the CEO and founder of Amazon.com. And these leadership principles are a curated list of behaviors that we expect to see from everybody that works for Amazon. There are 14 of them. Okay, we start with customer obsession and we finish with deliver results. And the other 12, we'll probably talk a little bit about later, but they can be mixed up. The ordering is not important other than the first and last, okay? And the first is customer obsession. This means that we don't just put customers at the heart of what we do, we put them everywhere that we do anything, okay? From having a new idea about a product to figuring out how we can better enhance an existing service, to prioritization, to communications. We try to embed that idea that customers are the most important thing in the organization in every single process and activity that we undertake. Now, I've worked in lots of companies that have said that before. I worked in a telecom company that had 5 values on the wall of every meeting room. Okay, and that's about as far as they went. They were on the wall of every meeting room, but they weren't really used. Okay, they weren't operationalized, they weren't reinforced, and diversions from them wasn't really ever addressed, and people were never really brought back in line. So you would have them, but didn't really do a whole lot. AWS and Amazon, it's completely different. Okay, we'll talk a little bit more about how these embed in our hiring process in a second. But for sure, we think about the customer and everything that we do. And we always try to work backwards from a customer problem in creating products or services or looking to improve how we operate. We use that as a mechanism for prioritizing what we do. So if you've heard about lean or stripping out non-value adding activities from an organization, one of the ways that we do that is by thinking about whether the opportunities that we have to do things actually positively impact the customer experience? Do they solve a problem? Do they help customers be more effective? Do they drive down costs? Do they shorten cycle time so that we can produce products more quickly that better reflect the needs of customers? If not, then we probably shouldn't be doing those things. We try to be frugal with our time. Frugality is another one of our LPs or leadership principles, and push those activities off the bottom of the list if they're non-value adding, if they don't help a customer move forward or help a customer solve a problem or help us serve a customer better. So that's really important. In terms of the way in which we create new services, this plays a really important role. So in creating new services, we have a process which is called the working backwards process. And we start with the end state, which we document as a press release. So we might, in the case of AWS, for example, write a press release for a new service that says something like the AWS Key Management Service is a service that makes it simple to create, store, and manage cryptographic keys in the cloud. You can use these cryptographic keys to encrypt data at rest as they integrate with other AWS services. So we're trying to boil down the problem that we're trying to solve into the simplest possible language, so simple that even a journalist can understand it. Okay, so really, really simple. And then from there, we'll also create something called an FAQ, frequently asked questions. So the full process name is the PRFAQ process. And here we're thinking about what are the questions that will be piqued from that press release. You might think, which AWS services do those keys integrate with so that I can encrypt my data? What kind of cryptographic keys? Can I upload my own cryptographic keys? Can I delete a key once I've created it? What happens if I delete a key? So you might have things that automatically come to mind, which are the next level of detail after that press release. Those two documents are fastidiously reviewed by our executive leadership team before we commit substantial resources to the project, and certainly before we start to design any architectures, write any code, or think about wireframing or any user interfaces. Okay, so that's our gate for intake into our product development process, the PRFAQ. And we do have executive oversight at this point with a really heavy, specific set of review inputs from our executive team. Okay, that enables us to frame the end state, and from there we can work backwards to create a product or service that fulfills the end state that we've defined. Okay, so the customer is at the very beginning of the development process. Then we will move through this development process, create the product, create the service, and we have several phases here. You can probably guess. We have a private beta process where we might work with a select group of customers to get their feedback about what it is we're thinking about building, maybe do some pre-release testing, maybe show them interface mock-ups or discuss their prioritization of their specific use case requirements in a little bit more detail so we can further refine what it is we're going to build. Then we have what we call a private preview. Private preview is admitting customers onto the service in a controlled way. It's normally in a restricted number of regions. Often the onboarding in the private preview requires the customer to do something or us to do something manual to onboard the customers. Okay. Then we'll have a public preview. At the point of public preview, we're ready for complete automation. Customers can self-serve to onboard. There's no gating. Any customer that wants to use the service can do so. Okay. Here we're normally in several more regions around the world. And at the end of that, we have general availability. The service is available. You can't go to public preview or general availability without having a customer ready to say, I am using this service. So we're closing the loop. It makes sure that we don't release services that are irrelevant. It's actually quite a big risk in technology, or that are not a good fit for at least a subset of customer use cases. So that's how we close the loop on working backwards from the customer before we launch services into public preview or general availability. It means we have a customer that's going to stand alongside us and validate what we're doing, but it also means that we have a proof point that customers will use the service in the state that we're announcing it in. And that works really well for us. I think there's plenty of examples in industry of technology projects that take a long time. By the time they're finished, the original use case requirements are no longer valid, right? Lots of examples of that in UK government IT that a lot of us can probably point and kind of smile about now, but we think about the amount of money that's been wasted building projects that aren't viable at the time of launch. It's actually not something to smile about. It's something where we really need to apply engineering and scientific methods in order to eliminate those kinds of issues. Okay, so speed is an issue here, it's a factor. And for that reason, we're very circumspect about how many requirements we let creep on into scope for the first release of a product. You've got to constrain it. Okay, there are things that you can't give up. Okay, we'll talk about those a bit later. But you can sure give up features in order to get a product out quickly and start to gather more data about how that product is used, and that's a good idea. Okay. So, next thing is experimentation. This is something I really like about Amazon. Experimentation is a data collection activity, right? So we want to do something to figure out whether or not a hypothesis that we have is true or not. Okay, so one experiment is I heard scientific method being mentioned in the closing keynote of this first session in the plenary this morning. So we do the same kind of stuff. The only difference, I think, is at Amazon, there's a real appetite for this. We want to encourage our teams to fail. Doesn't mean we want to impact customers. Okay, we want to do controlled experiments that allow us to gather data in a way which enables us to move our decision-making process forward. Okay, move our decision-making process forward with a really high degree of certainty. But there's a really high appetite for doing experiments. In fact, in the shareholder letter that Jeff Bezos writes every year, a couple of years ago he addressed this topic, and he wrote something like, and I'm not right by my computer here, so I'm not going to read this out, but more or less, Amazon is the best place in the world to fail, and believe me, we've had plenty of practice. Then he went on to talk about the Fire Phone, which was a very expensive failure. You know, we had a lot of unsold mobile phone handsets that cost a lot of money to establish a manufacturing and supply chain for that ultimately ended up being discarded, and we took quite a big balance sheet write down for that experiment. It was an expensive one, okay? But in general terms, what we're trying to do is equip our teams with the technology that they need to experiment at low cost and with very low risk. And actually the cloud is a massive component of this. If you can equip your teams with technology that they can use to self-serve in the experimental process without having a long wait time, if you can equip them with really robust frameworks for things like A/B testing, canary deployments, application instrumentation, data collection, visualization, analytics across a variety of different platforms, web, mobile, for example, you're then in a situation where you can enable your product teams to do their own experiments with their own apps, with their own services, without having to involve other teams. It enables teams to self-serve the experimental process, and that will, by definition, introduce a lot more experimental thinking. Because there's actually only one thing that drives up the number of successful experiments that you have, and that is doing more experiments, because you need to put more stuff in the funnel to get out more valid answers. Okay, because with an experiment, if you know how the outcome's going to look, and therefore you only do ones that are going to succeed, they're not experiments. Okay, they are ideas that you've already validated that you're proving. The idea with experimentation is you have to be blind to what the outcome will be until you run the experiment. You might have a hypothesis, but you probably shouldn't do an experiment if you already know what the outcome's going to be. So you need to fill that funnel. And filling that funnel at low risk and low cost is really helped by having a set of tools that are low cost and enable developers, product builders to self-serve in the experimental process. That's really important. On the organizational side of things, we try to constrain our teams to a small unit of size. This has got its own name within Amazon, which is the 2-pizza team. Idea here is your teams should be possible to feed your teams with a couple of large US pizzas. Now, I don't eat pizza, so I'd be a free team member. Okay, but in regular terms, we're looking at like a team of 12 to 14 people in size. Okay, and the reason for that is quite obvious, maybe. As teams get bigger, the overhead of communication gets higher. Okay, so it becomes harder to onboard new team members. It becomes harder to keep everybody in the picture. You get a scope for misunderstanding, miscommunication. You also get an overhead in hours spent every week keeping people in sync. So you can keep the team small. You can eliminate a lot of those issues. So how do we build big products with lots of complexity with small teams? Answer is we break the products and the complexity up into subunits. Okay, so we need computing resources to build a product. We're using our EC2 service to access the computing resources. We need an API tier to build our products, where we have an internal service that we are able to access that provides a standardized set of tooling for building API boundaries. Not just API boundaries, a lot of stuff to do with making APIs scalable, robust, documented, discoverable, but it's all there as a service we can use. Build tools like code pipelines, source code repositories, build engines, deployment. We have all of those available for our internal teams as services. Each one is run by its own group and provided to other teams as an internal service that they can consume. So your service or product team is concerned only with building the things that are unique to their specific product or service. Everything else is accessed as a set of service components that are, they're not forced to use them, okay, but robust, standardized, commonly used options are available. And if you put a robust, standardized, commonly used option in front of a developer, guess what? Most of the time they'll use it because they want to write code which they consider an interesting problem that might not have been explored before, not rewrite code that other people have already written hundreds or thousands of times before. So there's a push and a pull factor at play here. And of course, as products get bigger, services get bigger, we are able to break them up into smaller subcomponents and turn some components of those services into other services that maybe other teams in the organization can use, or maybe we convert them into external services that AWS customers can use, and we get not only a robust tooling substrate for our own team, but all of you as customers can access the same kind of technology that Amazon uses internally as well. Okay, so that's how we work on the teams. I said I'd return to hiring. So on hiring, we use those leadership principles for hiring as well. So if you come for an interview at Amazon, and I hope some of you do at some point in the future, you'll hear things from our team like, I'm going to not give an actual question, but give an example of a question. Okay, so tell me about a time you put the needs of a customer before your own. So it'll be a customer obsession question that we might ask. And then we're doing competency-based interviewing around those leadership principles. You'll get asked about a lot of them over the course of an interview, but we're trying to screen out candidates that don't have the same mindset that we're looking for, okay, and also don't operate the level that we're looking for a particular role. But we use those leadership principles to do our interviewing and to build our two pizza teams, fill our two pizza teams with the right kind of talent that we need to bring on board in order to build the right kind of products for our customers. We also don't overload. So when we start a new service team up as a result of this PRFAQ process, we're talking about a new team to build that particular service. So we're not going to load more and more services onto existing teams by definition, because if they did that, they'd have to grow larger than we want them to, right? So new service generally means a new team. And a lot of these teams have been created because forward-looking individuals in the org have thought, oh, that's something we could do. We could build a service or create a product around that particular problem, that particular domain area. And they'll write a paper, write their PRFAQ, get it signed off, and there'll be a team or general manager responsible for building that new service. And then they'll hire some people, transfer some people, build their core team, and they'll get to work building that product or service for a customer. But it'll be ring-fenced, and they'll only be working on that particular domain. They won't be taking those responsibilities on in addition to whatever they were doing before. That just doesn't work well for us. Okay, APIs. Talked about this a second ago when I was talking about our framework that we have internally. But actually the same thing goes for APIs that we expose to customers. You have to be very careful about design. Okay, very careful about not engineering yourself into a cul-de-sac. Very careful about building and designing APIs that are extensible. Curious to what's been looked at out there. Oh, okay, I see it now. So we're always trying to make sure that we design and build our APIs in a way which enables customers to use them easily. Okay, find commonality with mental models or with other services that they might have used previously, and doesn't result in us having to revise or change the structure of the API after the fact. Okay, any interface pretty much that you put out and give to a customer that is digital will ultimately end up being an API. To the extent that we've previously created web forms to access certain parts of our services or certain parts of our systems, and customers have ended up writing their own software to interface with our web forms, and therefore our human readable interfaces have actually become APIs that customers have built integrations into. So it's best to avoid that. Okay, and we always treat our application programming interfaces as first-class citizens, and quite often you'll see that services have API support before they have graphical user interfaces, or SDKs normally come at launch, but the actual ability to do things in our graphical console might lag behind availability of a feature for people that are using either the API or one of our supported SDKs. Okay, so we try to get that right first time so that we don't have to change things and cause work for customer during the life cycle of a particular service. Systems evolution. If you think about something like Amazon S3 that I talked about at the very top of the talk, this is our durable object store. When we launched that service, it was available in one region. There was one storage class, okay, and it was really, really simple without a lot of features. You could spend an hour to 2 hours today just doing a moderately deep dive about different features within that one service, okay? Take cryptography. There are 3 different ways that you can encrypt data within Amazon S3, and several of those options have different key storage options, for example. Okay? There are several different ways in which you can replicate data between regions. There are identity and access management features. There are ways to integrate Amazon S3 with applications that might be built for high-volume mobile platforms. Okay, so there's tons of features that have been built around the service, okay, in order to extend its capabilities and make it a fit for a wider range of different use cases. But Amazon S3 has never been taken down for maintenance during its life cycle of now over 12 years. Okay, so it's about evolving the system. Our CTO, Werner Vogels, described this in a talk once, which I thought was a really good way to describe it. It's like a single-engine Cessna took off in North Virginia back in 2006, and we launched the service. Now we've got a fleet of Boeing 747 Maxes that are converted for cargo transportation, flying all over the globe, okay? But the original cargo never actually touched the ground. We moved the cargo from aircraft to aircraft as we evolved the system over its lifetime. It's kind of a good analogy. Might have upgraded that Cessna by, you know, someone leaning out the window and fitting a new engine while it was still in flight. It's figuratively what happened with the service. So extension, but without having to cause customers downtime, or for that matter, change the programming model that customers are using. This is quite interesting when you consider that most customers access via SDKs. So if you're using one of our early software development kits, you still be able to use the same code to access data in the service that you could do when that SDK was first released. Okay. Under the covers, we might have changed things like the SSL or TLS protocols that are being used to ensure that they're secured in the right way. We might have changed things like extending the capabilities that are available within the API, but your basic code that you wrote all those years ago will still serve you well, because the system has evolved, but the interfaces have remained consistent. Automation. This is a super important component. Most people think about automation in terms of cost efficiency. So if I automate things, I need less people. Okay, that's true. Of course, it's true. But the bigger benefits come from speed and consistency. Here you can consider things like A/B testing. You know, I've got several different versions of my application I want to test. Well, with the right automation strategy, I can literally create several different versions of my infrastructure for those different versions of the application. Run those different parallel stacks for a few days, hours, or minutes, depending on how long I need to test for. Establish which one of them is the most viable evolutionary development in my application architecture or feature set, and then terminate the ones that I no longer need. That can be done using automation against our APIs. The other area, of course, where this is really, really beneficial is in things like continuous delivery, where I want to automate the process of creating infrastructure for new releases, doing so in a way which is both fast and, even more importantly, highly, highly consistent. Okay? Who's ever had an issue of inconsistency where they've had operators or human beings configuring infrastructure or systems? Absolutely everybody that's ever had anybody doing that. You're very much less likely to have that if you use programmatic-based models like infrastructure as code-based models to provision resources. What you specify will pretty much get provisioned the same every time, and if it doesn't, it's a bug which you can fix, and then it will get provisioned the same every time. So speed, accuracy, and efficiency, it's all wrapped up in automation. We have a lot of tools for this. One specific tool called AWS CloudFormation, which is a declarative language for specifying resources. I want a database, 6 machines, this network topology, this queue, these users, these trust models. Write all that down, run it through our engine. You get those resources. They're linked into something called a stack. I can tear them all down in a coherent way and stop paying for them, or I can make a new copy of the same thing with these 2 or 3 different changes for the next version of my app. I can even do that whole thing as a CI/CD pipeline, so I can continuously deliver infrastructure as well as the software products that run on it. You couldn't do any of that stuff without APIs and this automation layer. Other tools are available as well, like HashiCorp Terraform, which some of you might be familiar with. Similar sort of model. There are some design trade-offs between those 2 products, by the way, so if you are interested in the differences between Terraform and CloudFormation, you can certainly talk about that. It's quite an interesting philosophical difference between the 2 different products. Then information security. This is one of the most interesting things that I've seen in my time at AWS. I've been at AWS just coming up to 5 years. 5 years actually in about 3 weeks' time, so quite a long tenure. Been at Amazon longer than over 90% of the employees with 5 years tenure. It's kind of crazy. When I came on board, if you ask CIOs, CISOs, or CTOs, why don't you do more with the cloud? With AWS, quite a few of them would say information security and privacy are inhibitors. Okay. Today, if you ask CIOs, CISOs, and CTOs that are doing a lot with AWS what the main benefits are or why they're accelerating adoption of AWS, quite a lot of them will say information security is better in the cloud than it is in owned and operated infrastructure. Privacy controls are better. We have less to do. Lots of security management is just undifferentiated operational heavy lifting. Patching machines, managing users, copying credentials, rotating credentials, making sure that you've got appropriate auditing in place, forensics, verifiability. All these kinds of things are hard and often require specific software products and or people to do. Everything that I've mentioned there is available as features on AWS, so you can turn on enhanced auditing with a service called CloudTrail. You can use that KMS service for encryption with multiple crypto keys with specific encryption domains. You can automatically rotate secrets and credentials using something called AWS Secrets Manager. You can patch your machines with a service we have called EC2 Systems Manager. So all of these capabilities are integrated into the platform. We have a single open source agent that we can deploy down onto your EC2 machines, your virtual machines running within EC2, your instances, to help you do things like security patch management. These are all features that we've built over the course of the last few years. There's a ton of security capabilities there. And then secondly, compliance. So we have PCI DSS, ISO 27001. Everything we do is GDPR ready and was GDPR ready 6 or 7 months before the GDPR effective date. So you can build these compliance requirements really quickly in the cloud by building on top of the compliance substrate that's already present. That doesn't just go for AWS, by the way, that goes for many providers, but it allows you to shortcut a lot of the work associated with reaching a high security bar or achieving a specific compliance standard that you need to achieve. So it's a complete reversal in customer perceptions over the course of a 5-year period. And we all know how, traditionally, how conservative people in InfoSec have been. Okay, so getting them to turn around their viewpoint so quickly is actually kind of stunning when you consider how far they've come so quickly. The other thing I said I would talk about is core characteristics of services. So before we launch anything, we are interested in security, reliability, and the scalability of the service. And as I said, there's some things that can't be negotiated. Those are the 3, I would describe them as core characteristics of everything that AWS does. It's reliable, it's secure, and it scales. And then we can add features later on. That's why we say security is job 0. Before you can add any features to a service, you need to have security by design integrated into the service at day 1. Okay, so that's a really important tenet that our teams will work by and live by when creating new services. We have specific service offerings, by the way, for application security verification, which are used internally within AWS as well as available to customers. This is something called AWS Inspector, which is a very sophisticated application behavior monitoring package that you can integrate into a build or continuous integration pipeline and baseline the characteristics, behaviors of your app, and then receive alerts if that application deviates from that baseline. So literally say, this app modifies these files, communicates with these systems on these ports, and does these other things, which you write in a spec, and then you can continuously test the application against that specification. If it does something unexpected, you know that you've got a potential security issue that you need to investigate. And then lastly, this I think has been the biggest shift within Amazon from having AWS available as a tool set. Okay, and it's something that many enterprises can find kind of a little bit unconventional, a little bit scary. We think it's important to empower developers and empower technical teams to build. Okay, and we think that they should have free and unrestricted access to services that help them get their jobs done. Okay, and that's kind of that sounds like it's a risky thing to do, because free and unrestricted access means that you need to do things like manage compliance in a situation where developers have a lot of self-serve capabilities. Okay, so this is where the security features and the philosophy of AWS kind of take things in a slightly different direction, which is we want to create a service environment where you can provide guide rails for teams. Okay, so it's actually hard to impossible for them to do something outside of the guide rails, but within the guide rails they can move at their own pace. Okay, when we talk about no gatekeepers, that's what we mean. We kind of turn the gates into constraining walls that ensure that developers, product builders move in a way which is consistent with organizational policies, whilst at the same time being able to go really, really fast. Okay, so that's a really important concept to think about when adopting AWS, when using the cloud. A lot of it is about speed. You know, it's about compressing that cycle time down between having an idea, running an experiment, getting data back, making a decision, and implementing, and then running an experiment again and again and again. And it's through that iterative model that we build better products. Okay, so the more you can compress that cycle time, the more you can shorten the time from idea to experiment to results to decision, the faster you can evolve products and the more closely you can match the actual needs of your customers at any particular point in time. That's how we think. Okay, so that's part one. Does anybody have any comments or questions about anything they've seen there? Yeah.
What was the open source patch management thing you were referring to?
So it's an AWS service called EC2 Systems Manager, okay, which allows you to run an agent on your EC2 capacity, your EC2 machines, and from there you can initiate commands. Okay, those could be simply running commands on hosts, or they could be commands to manage revisions to software, or they could be inventory commands, whatever you wish. We have that as well. That's called Amazon Inspector. Okay, that is a proactive security scanning tool. It's agent-based, and we also just this last couple of days announced an agentless network scanning capability for that product as well. That's called Amazon Inspector. Yeah. Yeah.
Can I ask, the PRFAQ model that you have, is that typically at an MVP kind of level, or do you write that and then downscope to an MVP and build?
So the simple answer is I think you'd find it pretty hard within Amazon to find anything that is a strict MVP, okay, because we will not compromise on security, availability, and reliability, okay, and we have and scalability. So we have certain criteria in mind that I think mean that the traditional concept of an MVP is kind of challenging. Consider this. We've got millions of customers using AWS every single day. Okay, lots of software developers. And those software developers are often very excited and interested in new services that we release. Okay, so take something like our container management service, ECS. We have another one as well for Kubernetes, but we have an in-house tool. It's very, very heavily used by extremely large customers. Okay, so things like cluster size, we have to be able to go like to 11 out of 10 with attributes like that at launch. And we have to make sure that our services are robust for usage by very, very large consumers of the platform. So I would say the MVP-like characteristics that we have are more on the features side of stuff than they are in those core attributes. And ECS is actually a really good example of that. When we shipped the first version, we didn't have a console. It was a CLI only. So to provision your clusters and to launch container-based tasks onto those clusters, which are analogous to Kubernetes pods, you had to use a CLI tool. There was no pretty GUI with point-and-click capabilities. Okay, so that was outside of the scope of the MVP, but we did have those core attributes available in the service at day one. So I'd say we have feature MVPs, but we don't have MVPs on those core attributes of security, reliability, and scalability. Okay, so let's move on. Oh yeah, question at the back. So the question is, do we have requirements on operating system age or on patch compliance? Not really. Okay, so customers can run old operating systems within AWS. If you have something in your environment that we assess as posing a risk, okay, we'll notify you. For example, if you were to travel back in time, okay, and start an EC2 Linux instance that had a copy of SSL on it, OpenSSL, for example, that had a vulnerability, we would be able to see that because we would know which Amazon machine image you had bootstrapped that particular fleet of instances from. And if that's the situation that you're in, you'll find email hitting your registered account address warning you that you've got vulnerable software installed on your machines and that you should update them. Okay, but if the state of your machines in that non-updated state does not pose a risk to any other AWS customers, then we won't force you to perform an update. We will recommend that you do, okay? We may contact you proactively and warn you about that, but we wouldn't force you. Conversely, if there's something in your software which does pose a risk to other AWS customers or results in your systems being used for network abuse, then we will contact you and we may warn you about an account suspension and we may suspend your account. Let's just say you've got a machine with a vulnerable MTA, mail transport agent, which has been used to send out high volumes of spam email. Okay, that could pose a risk to other AWS customers by diminishing the reputation of our address space. So we would contact you about that and we may suspend your account in that case. And then we've got platform fixes. Underlying your EC2 instance capacity, there are, believe it or not, hypervisors and actual physical CPUs, okay? And that software needs to be maintained. And we have tools and techniques in place that allow us to do that in a pretty much non-disruptive way. Okay, so you may get instance retirement notifications, you may get instance restart warnings in some edge cases. And again, you'll receive those via email or you'll receive them in the AWS console using a new feature called PHD or the Personal Health Dashboard, okay? And you'll see your notification numbers there, analogous to what you'll see on your phone when you have a notification saying, look here, you've got 3 messages. And you might have a warning saying you need to stop and start instance ID number XY. That will result in your instance moving from one piece of hardware to another, potentially onto a different software stack. Okay. We might also do the same if we detect degradation in your underlying hardware. Say you're running on a SSD boot drive, SSD instance store, for example, which is kicking up errors that we can see within the platform. We may send you a notification encouraging you to move your workload to another instance in order to mitigate risk as well. Okay. Does that answer your question? Did you have? I'm going to repeat it, so shout. Yep. So the question is, how does AWS interact with open source communities, really? And the answer to that is, we participate in them and we contribute to them, and we're doing that an increasing amount. A good example would be the Cloud Native Computing Foundation, which is the umbrella body responsible for Kubernetes and a wide variety of other projects associated with container scheduling, container networking, and container security. We're a platinum sponsor of the CNCF, so we pay them money, and we've committed that for our Kubernetes service, EKS, all changes that we make to the code base in order to support our service will be contributed upstream and available as open source. We also have quite a few AWS projects, including our SDKs, lots of code samples, and quite a few other projects that are managed as open source projects as well, both in the core technology area and in areas like machine learning and AI. So we do quite a bit. And then on open source policy, you can also run open source software on AWS. I mean, this is kind of obvious, but there's 3 ways that you can use AWS. Let's take something like messaging, okay? So middleware, streaming data processing, this kind of stuff. Option 1 is fleet of EC2 capacity that you manage. On there you install ActiveMQ, RabbitMQ, Kafka, Apache Flink or Flume. These are the projects that enable you to manage streaming data, right? And you manage it yourself. That's option 1. You have a really broad choice, but you have a lot of work to do. Option 2 is managed services. ActiveMQ we provide as a service under the brand name Amazon MQ. We'll spin up your ActiveMQ cluster for you. We'll manage versioning, security patches, failure management, auto-scaling, all of the things that you need to operate it. It's still ActiveMQ at the core, okay, but we provide a management wrapper around it. You pay a few cents extra for that, of course, a few dollars extra for it, but you have a lot less work to do. It constrains down the product choices that you have to a much smaller number, because it's only the ones we're supporting, right? But that's an option. We have the same for databases as well, MySQL, Postgres, MariaDB, okay, and we have the same for Kubernetes with our EKS service, where we provide managed service around it. So there's that option in the middle. And then you have Amazon proprietary. We have a service called Amazon Kinesis. Incredibly reliable, ultra high volume, ultra high throughput data streaming and ingest service. We productized the service platform that Amazon Web Services billing was running on in order to create this service. Event volumes that would blow away anything seen pretty much anywhere in the industry. Supercell, who are a mobile gaming customer, I think they're doing, this number might be wrong, but I think they're doing 80 billion events per day through that service. Okay, so ultra high scalability. Our container, say again? Yeah, and Boom Beach and all of the other titles that they have as well. Yeah, so I mean, you're talking about mobile games that have tens of millions of concurrent players all generating events at the same time. That's where the data comes from. But the point is the services are ultra scalable, okay? But they are AWS proprietary services that you can't take out and run somewhere else, but you benefit from scalability, zero management overhead, very tight integration with our platform for things like security and identity management. So you basically have 3 options: run it yourself, open source services with management, or AWS specific offerings. You determine whether or not openness is key for you, or whether the scalability and reliability characteristics that are built into many of our services are key to you, and you can put the slider where you want. I think one thing that is important to say about open source projects, and by the way, this is not a criticism because I've used open source pretty much since before I started working. I had Slackware 2.1 back in 94, I think it was, when I started with Linux, so a long, long, long time ago, probably before a lot of you started working. So I've used it my whole life. But you can't get away from the fact that contributions to open source projects fit into a bell curve, okay? There are some people that have use cases that are small scale and are infrequently seen and therefore don't get addressed by maintainers. There's a bell curve where the majority of users are, where the majority of the use cases are a good fit, and that's where the projects have really good feature coverage and get a lot of development. And then you've got a small number of ultra high scalability or edge cases at the end, and those don't get addressed either. So if you're in the middle of the project and you fit in the kind of normal customer profile, open source projects are great. If you're out at one of the edges, you're not going to get the features that you want as quickly as you might need them in some cases, okay? So there is a bit of a trade-off there just to bear in mind. Okay, anything else? Yes? Yep. So the question is about migration. First thing is, we have services for migration, of course. We have physical data transportation services, something called the Snowball, which is like a 100 terabyte ruggedized disk subsystem that you can move from place to place filled with data. So that's one thing. We have database migration service, which has migrated over 80,000 relational databases to AWS. That'll inventory the schema in your relational and some non-relational databases as well, and allow you to move data to the cloud. We have open source tools of the type that we've been chatting about, where you'll have commonality of platform across different providers. And of course, you can also bring in and run Microsoft and Oracle workloads perfectly well on AWS, and it's very common for customers to do that. And we've helped thousands and thousands and thousands of customers do these kinds of migrations. Okay, so it's not unusual to do that, and it's certainly something that we support and work actively with customers to help them achieve. How complicated is the thing you want to migrate? Of course, is the answer. So it depends. We have a lot of tooling that speeds it up, but the main thing is enterprises are complicated, and you'll know this. Evolved complexity always beats out design complexity, right? So you've been running technology for 5, 10, 20 years inside an enterprise. You've kind of got to unpick it, and it's a little bit like a plate of spaghetti, right? Looking to the other people in the room that have grey hair to nod their heads now and say, yes, it is like a plate of spaghetti. So you've got to unravel all that in order to do a migration like that. But we've got lots of customers that have done it and lots of partners that help customers do it as well. Yeah. Okay, let's go. I'm being waved at. So AI and machine learning at Amazon. This is an area that I wanted to talk about. It's obviously super hot and interesting for developers, product builders, and businesses as well. And it's an area that we've been focusing on for a long time within Amazon.com. Okay, we use AI and machine learning all over the place. One of the places we use it is in Amazon Logistics. What you're looking at here are I can't kill the sound, so if there's a remote control to kill the sound, that would be great. What you're looking at here are fully autonomous materials handling robotic systems. So this was created by a company called Kiva Systems, which Amazon was fortunate enough to acquire, and it transforms the way in which our fulfillment centers work. The original vision that Kiva Systems had was, wouldn't it be great if we could just teleport the inventory into the hands of the people that pick it, so the pick workers, as you call them. So they just stand still and put out their hand, and there's a new product there for them to put in the box, so they won't have to walk around the fulfillment center. Okay, and that's precisely what happens. But instead of teleporting it, we just bring a series of robots past the person. They just put the hand out, and the product's there, ready to take and put in the box. Okay, so it gets shipped out to you quickly, efficiently, very, very accurately. Okay, you can have tens of thousands of these in any one fulfillment center. What they're doing is picking up inventory and moving it around, and the place they take it to is the pick station. Okay, and we use ML to navigate the robots autonomously within the facility. We also use machine learning to lay out the inventory in an optimized way as well, to ensure that the right inventory is in the right place based on the volume level for that particular product item, that particular item of inventory. So that's one use case. A second use case is in recommendations, and you'll all have seen this, of course, recommended for you on the Amazon.com or Amazon Co UK homepage, and customers who bought this item also bought. Okay, so it's a factorization machines type of workload where we're trying to predict what the next most likely thing for you to buy is. Okay, it's quite effective. Netflix do the same thing for their recommended for you system on their app, okay, and they derive 75% of their video views out of that recommended for you box. Okay, so it's a super effective feature. It's quite difficult to do at high scale. Like, we have millions of customers down one side of the table. This is the fact table, and then across the top, millions of columns of product inventory. Okay, and you might have this very sparse big data structure called an SVM or sparse vector matrix. Every so often you've got an intersection where you've got a non-zero number indicating that a customer bought an item. A column is set to non-zero in a particular row. And if you're a repeated purchaser, like I am for things like sad Wi-Fi light bulbs, trying to get all of my house onto voice control lighting. So I bought a lot of bulbs. Now I get a lot of lighting products because that bulb's number's got like 20 in it. So I think there's commonality with a lot of other lighting products for that reason. So that's a very, very popular use case. Thankfully, this algorithm scales really well across a cluster, and you can run training jobs across multiple machines. But we're using something called factorization machines to build that. And then we have enrichment of existing products. Tell the story of a character in Game of Thrones by figuring out who the important characters are using topic modeling. First of all, you've got to transcribe the audio into text, using speech to text, using a sequence to sequence translation algorithm. Then you're going to do topic modeling on the generated text to figure out who the characters are. Then you can index that and make it possible to see the story of a particular character in dialogue. Okay, but then we've also got video content. So there we're doing facial recognition, object tracking, and indexing the video content as well. And this enables you to do something like watch the story of Khal Drogo, and it will show you everywhere in the dialogue that he appears, and you can watch all of the video segments where his character appears in the storyline as well. It's done with ML. And then it also works on the app, so you can pause your video within the iPad or Android tablet versions of Prime Video, and you can see who's on screen, what else have they appeared in, uses facial recognition, object tracking. This data comes from IMDb. We also do fingerprinting on the audio tracks, so you can buy or listen to the music that you're hearing in a video as well. And then we have new products. We have this. This is Prime Air, so this is autonomous drone-based delivery. It's currently in trial close to Cambridge here in the UK. This is actual footage of the trial in operation. So customer orders, the item gets loaded onto a drone, the drone takes off, and the drone flies to the customer's house using GPS waypoints, but autonomous hazard avoidance, deposits the parcel, picks up and flies back again. Okay. So we've got a computer vision model on here which enables us to navigate around objects in the built environment, around trees, cranes, buildings, cars, people, land safely, and then return to base. Okay, and this is required because in the rural environment it's very simple, right? Things don't change too fast. But you look around here, how many of these buildings weren't here 5 years ago when the map was last drawn or the last 3D model of this city was created? Okay, so with this kind of technology you can operate autonomous drone flights safely inside urban areas. That's a good question. Yeah, I don't know. I guess it minimizes the flight time, doesn't it? If you're landing, and you don't need the extra motor to wind the item up. So that could be a reason. To be honest, they could drop the popcorn. Wouldn't really matter, but I guess was the Fire TV in there as well? Might get damaged. Yeah, so that's the autonomous flight, and that uses edge inference. So the inference model, the computer vision model, is on the drone. There's no Wi-Fi or 4G connectivity required for this. It can literally operate autonomously free of radio connectivity whilst it's in flight. And then we have this lady, Alexa. Probably all interacted with one of these devices as we're here in the UK. Great wideband natural language understanding and automated speech recognition system. What's the weather in London? Set an alarm for 4 AM. Play Little Mix on Spotify. How long will it take me to drive from York to Manchester? Can you order me my last takeaway from Just Eat, please? Yada, yada, yada. Supports extension skills, so anybody can create a voice-powered application using something called the Alexa Skills Kit. There's a very simple developer environment for that with an SDK. Get your skill approved, put it into the Alexa Skills Store. Anybody that's got an Amazon Echo in the regions where your skill is available can activate it and interact with your application or service using just their voice, and they take advantage of and use our natural language understanding and speech recognition capabilities. Very, very sophisticated language models are in use here, and it's a really magic experience. It's like something that a few years ago would have only been in Star Trek. Basically, they used to speak to the computer, and people used to be like, haha, that'll never happen. And that's actually what you do now. Turn on my landing light, and my landing light comes on. Great, absolutely amazing. So that's something. And then we also have this. This is Amazon Go. This is a retail experience in Seattle and in several other locations in the US now, where you can literally scan your phone, walk in, pick up a product, and walk out again, and you'll get a bill on your Alexa app, on your Amazon Go app, on your phone, a minute or so later, saying you took a chicken salad, a natural cold brew coffee, and a box of pineapple, for example. And there's no cashiers. It's done with computer vision and what we call sensor fusion. So sensors in the built environment that enable us to match products to people and bill those products back to those individuals' Amazon accounts. Okay, so tons of work within Amazon, tons of product innovation, some visible, some invisible, which is powered by this kind of technology. So what are we doing at AWS with this? Well, we're trying to put these kinds of capabilities into the hands of every developer and every data scientist in the world by building reusable services for machine learning developers of the type I was talking about before, reusable components that developers and product builders can use so that they don't have to build all of this stuff from scratch themselves. There's a lot of, as in most areas of technology, a lot of layers of software and a lot of layers of knowledge that are required to enable developers to do this stuff. Much of it is highly, highly specialized. I could ask a question like this, a simple question like, who can explain to me what the Hello World application is for computer vision using a deep learning neural network? Has anyone done it? Handwriting recognition of digits? Has anyone done that? 2 people. Okay, so there's 2 people here that have some rudimentary knowledge of how to build a classifier, an image classifier, using a neural network. Okay. Who would like to build systems that make it possible to extract data from written documents or text or from images? Who thinks that could have a potential application within their business? Who here deals with forms of any type? Number plates, faces. So you can all benefit from using image recognition, neural network technology, but only 2 of you have ever encountered the topic. Okay, so what we're trying to do is provide a toolkit so that developers and product builders that have ideas that can benefit from using AI and ML can access these capabilities in a way which is simple and easy to use. Okay, and you 2 gentlemen have already experienced the field. You can go farther and faster using these platforms than you can doing everything yourselves. Okay, so what do we have? Well, the first thing is we have a lot of customers that are already doing this. These guys, Too Simple, are a Chinese autonomous vehicle startup based in Shanghai. They drove a semi-truck 250 kilometers across the US in class 5 autonomous mode. In other words, no human interaction, okay, using models trained on AWS. The Royal National Institute for the Blind are using AWS to generate lifelike speech to make written content available to individuals that have serious visual impairments. Even newspapers or low-run magazines or journals can be transcribed to high-quality spoken audio using sequence-to-sequence neural network models. Pinterest. Anyone use Pinterest? Pinterest has an image search feature in it where you can type in garden furniture or patio or gymnastics and be presented back with images of garden furniture, patios, and people doing gymnastics. But nobody's ever catalogued the images. It's using image classification with sophisticated neural network models to figure out what's the statistical commonality between images that have gymnasts in them. What's the statistical commonality between images that have garden furniture in them, tagging those images and making them searchable using human text. Okay, so there's tons of different use cases for this kind of technology. Predictably, the developer community that are working on these kinds of technologies is not homogeneous. Okay, so you have different types of developers that are interested in this particular topic area. The 2 people over here, I'll pick on you again, that said, yes, you've used MNIST. You probably can use some of the things at the bottom here. Okay, so these are frameworks: TensorFlow, PyTorch, MXNet, Gluon, and Keras. They're frameworks for building deep learning networks for particular purposes. You need to know quite a bit about machine learning in order to use them, but if you do have that knowledge, then you've got a powerful toolkit there that you can use to build special purpose tools. Okay. In the middle, we've got general purpose developers, probably most of us that write code, that think it would be cool to have a classification model to figure something out, or another machine learning use case that we have in mind, but we don't have the domain knowledge to build our own algorithms or build our own neural networks. Okay. And then at the top, we have the accessibility developer that just wants to have speech generation, just wants to have natural language understanding, just wants to have image classification, but they're happy to do so with a common model that's been trained for them. Okay, so basically fall into 3 categories. And what we've done at AWS is try to build services that address all 3 types of persona. So in the bottom layer, we have high performance computing capacity, and we have software, which is maintained software packages to make it accessible. Okay, so if you do want to use one of these frameworks like TensorFlow or MXNet or PyTorch, we'll bundle that up into a maintained software distribution, and we'll make it available for you on an elastic basis. So you can train your machine learning models really quickly and with really good economic characteristics. Many of these algorithms scale linearly, so you can run 100 machines for 1 minute, and it will cost you the same as running one machine for 100 minutes. What I said before about shortening the cycle time on experimentation, well, that's basically what this does. It allows me to train my models more quickly so that I can figure out if they work well or not, or better than the previous generation or not, close the loop on my experiment, and either move forward or start again. Okay, so this is the low-level compute capacity plus the software to help you get things done more quickly. Then, this is really interesting, in the middle of the stack, we've got a tool chain which is intended to shorten this process, and I'll talk about it in more detail in a second, down from 6 to 18 months to hours or a couple of days. Okay, and this is a service called Amazon SageMaker. It is a tool chain for building machine learning models, a little bit like a tool chain for building software. So in a software tool chain, you'll have an IDE, you'll have a continuous integration, build and test environment, and then you'll have a mechanism for deploying your software out into production, right? So here we have a machine learning IDE, which is actually a Jupyter notebook, so an interactive programming environment for Python developers to build an experiment with machine learning models. Also, there's a lot of work here quite often in data preparation. You can do that in the same environment as well. Then we have the ability to train models in a way which is really simple and accessible and very, very scalable. When I say scalable, I'm not just talking about training one model. You know, imagine if you could build 50, 100 versions of your software product with slightly different characteristics, figure out which of those 50 to 100 versions is the best for your particular use case, and then keep that one. That's exactly what you can do with this tool. You can train 50 to 100 different machine learning models with different parameters, different characteristics, and then scientifically figure out which one is the most effective and keep it. Okay, so it allows you to automate a lot of the experimentation that comes with machine learning model development. And then you can deploy that behind an API endpoint and start to use it to make predictions about the world, or do inference, as we call it in ML. So you then have a very easy deployment model where you can put that model behind an API endpoint and start using it for predictions. You know, what's the most likely product that this customer is going to buy next? Is this a hot dog or not? Your particular use case is. So that's the tool. And then this has also seen lots of usage. Good, interesting example, hotels.com. So there's a correlation between the image that you see on a hotel booking website and how likely you are to book a hotel. Things like toilets or bathrooms, turns out they don't perform too well. But beautifully manicured rooms or lovely restaurants or welcoming bars or beaches perform well in getting people to book hotels. Agree? Also turns out that it's harder to predict than you might think what the characteristics are for attractiveness. Okay, because there's kind of many different features that you might consider make a photo attractive. So what they've done is they've trained a custom model on images for a kind of nebulous image characteristic called propensity to book. So they've got loads of data about how likely customers are to book a hotel based on what image they see on the listing. And they've created a machine learning model that allows them to pick out images that are more likely to result in people booking and show those automatically on the hotel page rather than other images that they might have as well. Okay, so that's one example. Another example might be Digital Globe. So this is a really interesting use case. Trying to figure out in areas of the world that are unmapped where people live. It's very easy for us in the West, particularly in the UK, which is a tiny little country. Okay, we've got one of the best state-owned mapping services in the world in the form of Ordnance Survey, right? Anybody that's ever been out in the countryside in the UK knows about these maps. They are amongst the best in the world. We have 100% coverage of the country, and they're almost perfect, right? Go to Sub-Saharan Africa, where you really need mapping because you want to do things like provide a minimum standard of healthcare or vaccinate children to stop them dying from preventable diseases, but even the government don't know where the population centres are. That's a reality. What Digital Globe did was train models using annotated mapping tiles to enable them to say, there's a high from this satellite photo, there's a high probability that there's a settlement here of this size. Therefore, there should be a vaccination station here, so you can cover these 3 settlements. And that's precisely the project they ran. They ran an open data hackathon with machine learning applied to mapping data, and they were working on vaccine placement in sub-Saharan Africa to ensure that they get the maximum possible coverage for preventable disease prevention for the minimum NGO dollar investment. Yep, so there's a question here about situational bias within machine learning. And of course, you're right, it's a valid observation. So you have to understand the domain. In fact, understanding the domain and doing something called feature engineering, which you probably got some familiarity with based on what you just asked, are actually 2 of the more difficult parts of the problem. So what is it that I want to answer is the first thing. And we all know working in IT that technology, getting the requirements in a really crisp way is actually surprisingly difficult quite often. Yeah. And then the second thing is controlling for bias, which is exactly what you've talked about. So there's whole graduate level courses now being taught on bias elimination in machine learning. So it's definitely an area that it's worth digging into and thinking about more. Yeah, I agree. So I just wanted to illustrate a couple of examples. I'm sure you'll recognize every other customer on there. Edmunds.com is in the don't know them so well, customer American, but it's like Direct Line in the US, basically. Really large scale direct to market insurer, motor vehicle insurer. Okay, so that's in that platform there in the middle. Then at the top, we've got recognition, transcribe, translate, poly, comprehend, and lex. You can probably guess what most of them do. Image recognition, classification, facial analysis and comparison. Facial analysis is like, he's happy, he's sad, he's 42. 45 in my case. He looks male, for example. Transcribe is the speech to text, English and Spanish, sequence to sequence translation. Translate is English to French, French to English, French to Russian, traditional Chinese to German, 133 different language pairs. This is something called neural machine translation, which is context-aware machine translation from language to language. Poly, I'll talk about in a second. Comprehend is topic modeling, entity and sentiment extraction, key phrase extraction, language detection. It allows you to process text using deep learning techniques. And Lex is a language model with the same kind of characteristics, but directed specifically towards building natural language interfaces, audio or text-based natural language interface. So you can sort of take out a special purpose chatbot that you might build on Alexa and embed it in your own mobile app. And the same for text, putting it out onto Facebook as a chatbot, for example. Poly, I said I would return to. So this is just an example of the kind of features that are available in some of these cases. This is speech generation, 52 different voices across 25 different languages. Okay, so here it is. You give it a fragment of text and it will render back to you. Hello, my name is Joanna, or whatever you type in. Whatever you type, I will speak whatever you type here, it says actually in the demo. Hello, my name is Joanna, I will speak whatever you type here. And we support 25 different languages, all the way down to Icelandic. Very, very niche, okay, as well as a lot of heavily spoken languages around the world. You can execute or exercise fine-grained control over the audio rendering. So it's not just for what I would describe as functional voice, you know, navigation system you might describe as functional voice, okay? It can also be for creative use cases, like I've got this cartoon or audio book that I want to voice. So it's important that I can have different voices in the same language for different characters. It's important that I can control the timbre, as they call it, the speed at which the voices speak to give them some personality. maybe even have features like whispering, which is also included. So there's a markup language called speech synthesis markup language that you can use to effect this fine-grained creative control over the rendered voices as well. Very, very popular. Okay. And that's also been used really extensively all over the place, from navigation with Mapbox through to education with Duolingo for language tuition using artificially created voice, quite interesting. And then RNIB, which I talked about earlier as well, using that service. Okay, so I'm going to wrap up there. Just say that our objective here obviously is to create these really simple, easy to use services that match the needs of different developer personas that have an interest in building these machine learning and AI use cases. Why should you use the cloud for this? Well, the first and most important and the last thing that I'm going to say about that is, where does your data get generated? Okay, most new data gets generated in cloud computing platforms, and you'll know that data has gravity. It's difficult and time consuming to move data, especially at scale, away from where it is created to other locations. So it makes sense to bring the computing resources to the data rather than the other way around. And that is one of the reasons that AWS is such a popular place for customers building these types of machine learning and AI apps today. Okay, thank you.